you should find that property list. Just the extra properties that we've talked about in this chapter are those converses that we went over last week. And
good morning, attention staff and students. Please do not use the attendance kiosk for signing in today. All attendance should be taken manually. Thank you.
The other reasons that we went over were in section 2, I think, of chapter 3. That's the one where it said if parallel, then those angles are congruent or those angles are supplementary. So those are the only added extra reasons that we had for this chapter. Now, since we have a shorter schedule today, I'm going to skip over these 5, and I'm going to just start with our 2-column proofs here. That way you guys can have some time, I'm hoping, to work on your assignment. So, just like any other proof that we did last chapter, you always want to look at what you're given and what you're trying to prove. Okay, so I am given that ray AB bisects angle CAD. Okay, so this is CAD right here. And ray AB bisects that angle. What does bisect mean? Yes, it's in the middle. It splits your angle into 2 congruent pieces. Now I'm also given that angle 1 and angle 2 are congruent to each other. Okay, since that's given to me, I do want to label that. Okay, angle 1 and angle 2 are congruent to each other. Now we are trying to prove that segment AD is parallel to segment BC. Okay, so AD is right here. And BC is right here. So we're trying to prove that those lines are parallel. If I am trying to prove lines are parallel, I need to use a converse somewhere. Okay, that means I'm looking for congruent angles or I'm looking for supplementary angles, given those lines are parallel. Okay, so just like with all of our other proofs, we always start with our given information. Okay, so I'm starting with my given information. For my next statement, I need to use that given information. Okay, so since I have ray AB bisecting angle CAD, since this is a bisector, again, what do I know about these 2 angles? They're congruent, right? Okay, so whatever I label in my picture, I have to write as a statement in my proof. Okay, so I'm using that ray bisects this angle to say angle 1 is congruent to angle 3. Okay, why did I say that those 2 angles are congruent? What did I use?
Definition of bisect.
It is definition of bisect. I used a bisector. Okay, that's the definition of bisect. Okay, from here I've used this part of my given. Okay, I still have to use that angle 1 is congruent to angle 2, and I still have to use angle 1 is congruent to angle 3. Well, since I have an angle 1 and an angle 1, right, can't I replace this angle 1 with what it's congruent to? Yes? So instead of angle 1, I could have angle 2 is congruent to angle 3. Okay, so I replace this angle 1 with what it's equal to. That is substitution. Okay, now since I'm proving lines parallel, I need to look at where angle 2 and angle 3 are. Okay, so I have angle 2 is congruent to angle 3. Again, when I'm proving lines parallel, I want to look for a transversal, and I want to see what type of angle pair is created in that last line. Okay, so if I look at 2 and 3, what type of angle pair is that with this as your transversal? They are alternate interior angles. Now, since I'm proving that lines are parallel, I would use that they're alternate interior angles, and I have to use that converse. Okay, so you use that converse whenever you're proving lines are parallel. Okay, so if your last line is something's parallel to something else, you should be using a converse. Questions? All right, next one. Okay, so we are given that M is perpendicular to P. That's what that symbol means, perpendicular. And M is perpendicular to Q. Okay, so M is perpendicular to P. And M is perpendicular to Q. And we want to prove that P and Q are parallel. Now, with the proof I have at the right, this is how I want you to prove it. There's a different way to prove this as well, but this is how we're going to prove it at the right here. So, again, what do I start with? Given. Okay, I'm using that given information. Now, since M is perpendicular to P and M is perpendicular to Q, I know angle 1 and angle 2 are right angles, correct? Okay, that is the definition of perpendicular lines. Okay, you have your right angles created by those two perpendicular lines. Now, if angle 1 and angle 2 are right angles, we know they're congruent. Why are they congruent?
The right.
Because they're right angles, so what is it?
The right angle.
Because of the right angle theorem. All right angles are congruent to each other. Okay, that is the right angle theorem. Okay, so if I'm looking at angle 1 and angle 2, and I'm trying to prove that P is parallel to Q, what type of angle pair are created in line 3 with 1 congruent to 2? They're corresponding angles. So I can use corresponding angles with that converse to prove lines are parallel. So again, whenever you're proving lines are parallel, you use a converse. Questions? All right, I want you to try 7. Label your picture. It's only three steps. Label your picture. If you need your property list, find that in your binder. Take it out and use it.
So which one would you want to write? 6 is congruent to 5 or 5 is
Well, you already have 6 is congruent to 5.
that? So 5. Wow.
Yeah. So you don't want to restate the same thing that's already been stated in.
That one makes sense. Angle 4. And that's wrong. That's substitution. And then angle 5 is congruent to angle 4. And AB is parallel to BC because of CA converse.
I'm sure.
No. But it sounds like a good net. CA converse. Yeah, I got you. Thanks. All over my writing. That's how I put CA. It's CA. Oh, well, I know it's CA, but like, I don't know. I don't know. You literally just put C. No, it's like it's wrong. We're proving that the lines are parallel. Oh, wait.
Look at which lines you're proving parallel.
Oh. See, I told you. I don't know the answer to this.
Make sure you know which lines you're trying to prove parallel.
Okay, so it's BC and AB, so it is.
All right, so with number 7, we have angle 5 congruent to angle 6. So 5 and 6 are congruent. And we have angle 6 congruent to angle 4. Okay, and we're trying to prove that segment AD, that's this one right here, is parallel to segment BC. That's this one right here. Okay, well, I always start with my given information. Now I have to use that information to make my next statement. Okay, well, I see that 5 is congruent to 6 and 6 is congruent to 4. Both of these have a 6 in them, correct? Okay, well, then I can replace this 6 with what it's equal to. Okay, so I can replace that 6 with that 5. So I would have angle 5 is congruent to angle 4. Okay, and that is either the substitution property or it can be the transitive property. Okay, so next, since I'm proving that these two lines are parallel, I'm going to look at 5 and 4 and decide what type of angle pair I have there because I'm proving lines are parallel. So AB would be your transversal. They are alternate interior angles. So by that converse, those lines are parallel. Questions on that one? No. We're going to make them longer now. All right. Number 8. Nope. Okay, number 8. We are given angle 1 and angle 5 are supplementary. Okay, so 1 and 5 are supplementary, and angle 1 and angle 4 are supplementary. What does supplementary mean?
Add up to 180.
Add to 180. Okay, you have to keep that in mind. We are trying to prove that line J is parallel to line K. Okay, so somehow I wanted to get down to 4 and 5 are congruent to each other. Because those look like alternate interior angles if those two lines are parallel, right? So somehow I want to get it so 4 is congruent to 5. So I have to use that these angles are supplementary. Okay, so starting with my given, using my given, if angle 1 and angle 5 are supplementary, what could I write as a statement? Using those angles are supplementary, what could I write as a statement?
Angle 1 plus angle 5.
So if you're given two angles are supplementary, add them together to be 180. Okay, same thing with angle 1 and angle 4. Add them together to be 180. Okay, why can I write that? Yeah.
Definition of supplementary.
It's definition of supplementary angles. Okay, I was given that they are supplementary, so they can add to 180 by that definition. Okay, now using that I have these two equal to 180, right? So 1 plus 5 equals 180, and 1 plus 4 equals 180. Okay, I can replace this 180 with what it's equal to in that other line. Okay, so I have angle 1 plus 5 equals 1 plus 4. Okay, I'm replacing this 180 right here with what this 180 is equal to, since they equal the same thing. That is substitution. Okay, from line 3 to line 4, I want to see what changed because I've used each thing that I've written down so far. So I just want to see what changed into the next line. Well, I notice that I subtracted the measure of angle 1 from both sides of that equation. If I subtract something from both sides, what property is that? Subtraction, property of equality. I know the lines are small here. I put an equal sign for equality. All right. To get to the next statement, what do you think I have to do? To get to the next statement, what do you think I have to do if I'm subtracting something from both sides of an equation?
Property of opposites. So take
Just
up
subtract.
the measure of 1, so it'd be properties of opposites.
Just subtract those, so I have the measure of angle 5 equal to the measure of angle 4. If you write property of opposites, I won't mark it wrong, but that's not what I'm going to
But
write
it
it as.
is.
Okay, so this is just subtracting, so it is a subtraction fact. Okay, so I'm just subtracting those angles from each other.
Wait, is there a rule that it couldn't be properties of opposites? Or could it
I
is
usually
it like
use property of
substitution?
opposites just for algebraic proofs.
Okay.
From 5 to 6, I'm going from equal measures to congruent angles. Equal measures to congruent angles. Is definition of congruent angles. Okay, you use that to switch between your measures and your congruency. From here, since I know angle 5 is congruent to angle 4, I'm proving J is parallel to K. This angle pair now looks like alternate interior angles. So by that converse, those lines would be parallel. So again, only when you're proving lines are parallel should you use a converse. Questions on number 8?
We are ready for the homework.
Not yet. I have to do number 9 yet. That one's different.
So I know number
Wait,
1.
are mine right?
Huh?
Can you like really quick look at mine?
Number 9?
Yeah.
Number 9 is different, so it's close.
Like close enough that it like
Number 2, you have to write something along with that for your second reason. But everything else is
Is it a converse?
correct. No, not a converse.
Or is it like that with another?
No, it is that, but you have to write it differently.
Okay.
All right, so number 9, in this one, you're given that lines are parallel this time. You're not proving that lines are parallel. You are given they are already parallel. That means I'm not going to use a converse. Okay, you only use a converse when you are proving lines are parallel. Okay, this one I'm given lines are parallel. So I have P is parallel to Q. That means this line right here is your transversal. So you still have to look for these angle pairs in your picture given those lines are parallel. Well, I see that 3 and 4 would be an angle pair given those lines are parallel, right? Those are consecutive interior angles, so I might have to use that in my proof somewhere. Now I'm trying to prove that if I add angle 1 to angle 2, I get 180. Okay, so starting with my given information, that those lines are parallel, I remember seeing that I had an angle pair in my picture. Okay, that angle pair was consecutive interior angles. Okay, hence angle 3 plus angle 4 equals 180. Consecutive interior angles are supplementary. Okay, so this reason is the one we wrote at the beginning of the chapter. You have to write if lines are parallel, then consecutive interior angles are supplementary. Okay, you're given parallel lines, so you use if parallel. Okay, you already had that the lines were parallel. Okay, so you use if parallel, not a converse. Okay, so now that I've used my given information that lines are parallel to write this statement, next I want to look at my picture. Okay, I have angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. Yeah, what is that? They are vertical angles, right? Vertical angles are always congruent to each other. That is the vertical angle theorem. Okay, vertical angles are always congruent. Make sure you are looking back at your picture so you can see that in your proof. Okay, then from 4 to 5, since I started with angle measures, right, I was adding angles, so I used their measures. I don't want this incongruency to replace things, so I want to change those to equal measures. When I change to equal measures, that is the definition of congruent angles. Okay, from here, I want to use statement 5 and statement 2. In statement 5, I have 1 is equal to 3. I have a 3 here. What could I do? If 1 is equal to 3, what could I do here?
Substitute.
I can substitute 1 in for 3. Here I have 2 is equal to 4. So instead of 4 in that statement, I could replace it with 2. So when I replace those values, that is substitution. Okay, you replace those values, that is substitution. Questions? All right, work with, yep. Oh, because I took out a line. Don't worry about that. That was a good question. Yeah. All right, work with the person next to you. Do number 10.
Okay, so the first one we did in, and then
Alright,
after that,
so who wants to give it?
switching to, I think it's definition of congruent angles. And then, going from 1 to 3 is 180, so that would be, if it was parallel,
Okay,
then
so
consecutive interior angles are supplementary. And then substituting angle 1 in for 2 because of number 2, that'd be substitution. And then number 5 I said was consecutive interior angle.
number 2. So angle 1 is equal to
With this one, you have an if parallel reason and a converse.
number 3 is yeah, and then number 4 is the substitution. Wait, I have I'm first. Yeah. Yeah.
While doing the notes.
Yeah.
Kind of smart like that.
No, they're not corresponding.
And I'm so far behind right now. I don't understand.
It's not alternate.
And I auditioned for this stupid honors choir or whatever it's called for the album. And then he's like, oh, you have to take a different choir. I'm like, well, I didn't know I was going to get it. I wasn't expecting it. And he changed my whole schedule for it. And then he popped me up in the leagues. So now I'm turns out he didn't actually need to take another student choir.
Your angle pair, alternate interior. Oh. Exterior.
So
Do you know?
my mom always yells at me for not cleaning
Our alternate exterior.
I forgot that was a thing. Wait till I said she said there was a comment.
Okay, so number 10, really quick here, you have like 3 minutes. So I always want to start with my given information. Now, since I am given that lines are parallel, that means I have to use an if parallel statement. Okay, if you are given lines are parallel, okay, for your given, you have to use a if parallel reason. Okay, from that, I am also given that angle 1 and angle 2 are congruent. Okay, right off the bat, I want to change those to equal measures because I see supplementary things happening here. Okay, so I want to change that to equal measures by the definition of congruent angles. From here, I'm going to use that line A is parallel to line B, making line C its transversal. So I see this angle pair of 1 and 3 right here. Okay, those two added together are 180. Okay, so I'm using my lines are parallel. That means I have to use if parallel. Okay, if you're using lines are parallel, if parallel, then those are consecutive interior angles, and those are supplementary. That's the only angle pair that is supplementary out of all 4. Okay, from here I can use line 2 and 3, so I can replace the measure of angle 1 with what it's equal to. So I change it to a 2. That is substitution. And then my last line here, I'm proving lines are parallel, meaning I have to use a converse. Since I'm saying 2 plus 3 is 180, okay, line B is your transversal and C and D would be parallel by the consecutive interior angle converse. You have to look for those angle pairs. Okay, you have to look for those angle pairs to help you.